All right, we'll go ahead and get started. Thanks again for joining us today. We've got just a short one for you today. All of us are homeowners, renters, paying utilities, or maybe new or potential home buyers in the future. I thought I'd just go through some things that I've been asked a lot of questions from on a one-on-one basis, like casual conversations at conferences and conventions. A lot of people, when I go to those things, they ask about the energy code, and then when it's a one-on-one, they ask about their personal home. So there's just some things I wanted to go through today, just kind of, as I call it, what every homeowner should know. Um, there's a lot of people that we know and our friends, family, acquaintances that don't do what we do on a daily basis. So I know a lot of this stuff will be elementary for our audience, but I hope you guys have a few great takeaways that you can pass on to friends and families that don't understand the things in the way that we think of it because we see it every day and inspect it every day and go through it. So hope you guys enjoy it today. Just let me know in the feedback for the survey. As always, today's webinar is being recorded. It will be uploaded to our YouTube channel, which you can find either by searching Spear on YouTube, or you can go to our website at eepartnership.org, and under our news section, you'll find it under our resources page. Once you're on the resources page, you'll find the link to our channel. Within 72 hours of the presentation, you'll receive a course evaluation email from Kathy Lawrence. Please complete that survey and send it back to her to receive your course completion certificate that will contain the course ID you'll need when reporting your CEUs to ICC. Lastly, the chat feature is open, so please use that to report any technical difficulties you might be experiencing during the presentation. I'll also have the Q&A feature open as well, so please use that to post any questions that you might have, and we'll go through them during the presentation. So just as we always do, this is just some housekeeping here for an intro to Spear. Those that don't know are first time joining us here. Spear is one of 6 RIOs throughout the country. We're a member-based, nonprofit, 501c3 organization. We have 50-plus members across a wide selection of energy efficiency industries, such as product manufacturing and just other stakeholders or organizations that are doing kind of the same push that we do for adoption and advocating for the adoption and enforcement of the energy code, focused on outreach, education, and collaboration with clean energy. We actually provide training, webinars like this, in-person and field trainings, as well as I can also do a personal one-on-one IECC test prep if any of you are looking to be certified. The price is always right. It's free. This is what I enjoy doing on a daily basis. I can help with questions regarding energy code, ASHRAE 90.1, and help with your plan reviewers as well. If there's building officials on here that thinks that plan reviewers might need some refresher or some updates on the energy code, I can go through that. And then also third-party energy inspectors. I dealt 10 years or with 10 years for a third-party energy verifier. I've been out there red tagging builders, got to know the process pretty well. Now I'm on the other side of that trying to teach the energy code to inspectors. So I'll be happy to help in any way that I can. We've assisted several cities with the adoption of 2021 and how to navigate the additional amendments to lessen the impact of adoption. That's always a big thing when cities look to adopt it. They're worried about what the building industry is going to do in their area. My contact information will be at the end of this presentation, so feel free to reach out to me with any questions. And again, love to help navigate through energy code any way that I can. So today's agenda, we've got the basics of energy code. I told you it was going to be elementary. How energy codes impact home construction and renovation, energy code and home sales, the financial aspects of making improvements, and then ways to improve your home's energy efficiency as well. So let's get started. It's just the basics of energy codes. This basically just comes right off of Wikipedia. It's just you type it in, what are energy codes? Energy codes are regulations set to ensure energy efficiency in a building's design, construction, operation, aiming to reduce energy consumption, the environmental impact, and utility costs. They cover aspects like insulation, lighting, HVAC, and are enforced at various government levels through permits and inspections. There's not really a lot of consistency in that. That's kind of what I hope to help do with a lot of people that I speak to, is consistency in how it's enforced. And then compliance with the code is essential for promoting sustainability and addressing climate change by minimizing the energy-related environmental footprint. Used to, the energy code was all about just energy consumption. It's now morphing into more of a sustainability in how you address environmental footprints for greenhouse gas emissions. Of course, reducing energy consumption is one way to do that. So it's becoming part of the code as well. So the scopes of energy code. So the scope of the energy code refers to the range and extent of element systems and aspects of building design and construction that codes encompass and regulate to ensure energy efficiency and sustainability. That kind of in a nutshell, an easier way to see this is the main concern of energy code is, of course, energy consumption of a home or a building. Anything that can raise energy consumption of a home or building is modeled, inspected, and then tested to verify compliance. If all these things go as planned, then the energy consumption of the home or the building will be equal to or less than the estimated energy consumption of a virtual model built in a software called the referenced home. So the referenced home is a close representation of the home or building being constructed. It's located in the same location. It has the same size. It's constructed using the same techniques. If it's 2x4 walls, 2x6 walls, if it's stone or if it's brick, what the veneers are, which doesn't play a whole lot into that, but it's different colors of the building, has the same HVAC equipment, has the same insulation levels, including R value, U factor, and SHGC, and then should be close in orientation as the house being built. So if it's, you got north, south, east, and west as the cardinal directions, but you have northeast, southeast, southwest, it should represent closely how the house is going to be completed. So here's kind of a short list of what things are being verified. Of course, it's the building envelope. That's specifications for walls, roofs, floors, windows, doors to minimize heat loss or heat gain. And then the HVAC systems, standards for HVAC and heating and cooling and ventilation systems to optimize energy consumption. And then you've got lighting, which require both interior and exterior lighting systems to enhance energy efficiency. And of course, now we see in the 2021, they're bringing more controls into that. Not only are they saying you have to be 100% high efficacy lighting, now they're asking for more controls to control how often it's being used and not being used when it's daylight enough outside to be able to see. Water heating, regulations on water heating systems to reduce energy usage. Renewable energy integration, it's a provisions for incorporating renewable energy sources like wind and solar. And then appliance efficiencies, you got standard for energy efficiency consumption of appliances and equipment within the building. We all know if you're out there inspecting in the world that HVAC has gone through some advancements in SEER ratings. It's now listed as a SEER 2, which is a different way of testing the equipment to better formulate and get a more accurate SEER rating. We'll talk about what that means in a second. And then performance testing, requirements for testing and verifying the energy performance of various building components. Then you've got documentation and compliance, which are procedures for demonstrating compliance with energy codes through documentation, inspections, and certifications. This is the things that are turned in for permit documents. And then also at the end, at a final for some verifications of that. This is a long list here. But common terminology and what we always talk about, I always get accused of using way too many acronyms when I do presentations. I have a bad habit of just rolling off the tongue what I'm used to saying, and people are like, I have no idea what that means. So just go through some common terms you might be hearing if people are talking about energy efficient items or how things are measured. Of course, R value measures the thermal resistance of a material, indicating its ability to resist heat flow. The higher the R value, significantly better insulation properties. And then you've got U factor or U value. It represents the rate of heat transfer, not resistance, but how much actually transfers through a building component such as a window or a door. And then you got lower U factors indicate better insulating properties. These two, it's funny, these two are the inverse of each other. So to get one or the other, you divide that into one and you get the other. So for example, if a window has a U factor or U value of 0.23, then it has an R value roughly 4.35. So you just do the inverse and you're able to get that. So all of it kind of does the same thing, but R is resistance and U is the actual how much is transferred. And then you can inverse and they end up getting the same meaning as a result of referencing different ways of seeing that. HVAC stands for heating, ventilation, and air conditioning, referring to the systems responsible for maintaining indoor environmental comfort. They're getting smarter and smarter and smarter by the day. Home energy rating system, which includes HERS, developed by ResNet, or by BSI, which is a new one in Texas, the Building Systems Institute. And then you've got the home energy rating system as a scoring system that measures a home's energy efficiency related to the standardized referenced home. We just talked about that a minute ago, but that's kind of in reference to that virtual house built in the software. Example of numbers from that is 55, 65, 75. It's a 2 or even could be a 3-digit number that represents the energy efficiency of a home. It's also used easily to compare houses when looking at homes side by side. Even though they're not the same looking house, they may be different number of bedrooms or square footage. But if you look at the HERS score or the home energy rating score, then you come up with a number that can mean something to someone about energy efficiency. There is one called Home Energy Score, which is developed by the DOE and its national laboratories that has an online tool that's used to score a home or its energy efficiency, and it lists it between a 1 and a 10. So 1 being the lowest energy efficiency, more energy consumption, and then 10 being the highest energy savings. This can be found on the Better Buildings Solution Center's website, where you can locate a home energy score certified assessor who can perform the needed assessment or audit to score a home. If you know enough about how to do the inspections and how to verify certain items, you can go on there and look for, you can have one as just an example. You can have just it doesn't really mean much. It doesn't go anywhere. It's not a database, but you can play around with it and build your house into the software to try to score your house on how well it's doing and performing. So then you've got EER, which is the energy efficiency ratio. It measures the energy efficiency of cooling devices like air conditioning, representing the ratio of cooling output to the energy input. And for example, numbers here, you got 8.5, you've got 9, 9.5. The higher the number, the more energy efficient. Then you've got SEER, which we just talked about that a minute ago. Now there's also SEER 2, which is the new one. It still stands for Seasonal Energy Efficiency Ratio. It represents the efficiency of air conditioners over an entire cooling season, measuring the ratio of cooling output to the energy input. So for example, you've got 15, 17, 18, and even up to like 21 SEER, now SEER 2 ratings. Then you've got AFUE, which is the annualized fuel utilization efficiency. Those stand for the gas furnaces we have in our attics. Represents the efficiency of combustion heating appliances, indicating the ratio of useful heat output to energy input over a year. So a lot of times we have, for example, an 80% furnace or a 90% or a 94. The higher the number, the more efficient. 80% means it loses or wastes 20% of its heat produced. And then the closer you get to 100, it's more energy efficient. The building envelope or building thermal envelope refers to the physical barrier between the conditioned and unconditioned spaces of a building, including walls, windows, doors, roofs, all of that, whatever encompasses that to be the building's thermal envelope. You got daylighting, which is kind of more on commercial side, but it's starting to play more of a role in residential as things progress. It's the practice of placing windows, skylights, and other openings to utilize natural light effectively, reducing the need for artificial lighting. So when you get more into LEED and passive house and things like that, they start looking at how can we light the home without using energy to light it by natural means. Then you've got renewable energy. Of course, that's energy derived from sources that are naturally replenished, such as solar, wind, or geothermal. You've got passive design, which is building the design or home with the approach that utilizes natural resources like sunlight and wind to optimize indoor environmental conditions, minimizing the need for mechanical systems. Blower door testing, or some people just call it air sealing testing or air tightness testing. It's a test that measures the air tightness of the building and identifies air leakage. Then you've got duct testing as a test used to measure air tightness of the HVAC and its duct systems to identify leakage areas. Net zero energy building is a building that produces as much energy as it consumes over a specific period of time, like a year, typically through the addition of renewable energy sources like wind and solar. You've got demand response is a strategy to adjust energy consumption in response to supply conditions, such as peak demand periods to supply and demand efficiency. Sometimes we're looking at now in the 2024, the grid integration for thermostats and water heating. It's a way to, on demand response, to be able to change some of that. Thermal mass, which is not really used on today's construction. If you're building a custom home, some people look at that as being something you can play into this role. It's the ability of a material to absorb and store heat energy, which can be utilized for alternating the indoor temperatures. So you could have a large stone wall or a stone fireplace that is relatively close to south facing windows or west facing windows. As the sun comes through, that stone or brick or whatever's inside the home actually gets heated up. It stores the heat, and as it cools off on the interior of the home, that heat starts to re-radiate back into the house. It can offset the heating for energy consumption for heating the actual building itself. Thermovoltaic refers to the technology that converts sunlight into electricity, typically through solar panels. Understanding these terms is crucial for professionals, policymakers, homeowners to effectively communicate, implement, and comply with energy codes to enhance energy efficiencies and sustainabilities in a building. A lot of times people look at this as, we talk about this more a little bit later, but when you go to build a new house or buy a new house, it's more of the aesthetics that people are worried about. They don't truly fall into well, is this home going to be energy efficient? They're just leaving it up to the contractors to understand it, to be able to do the best for the house. So the next section we have here is how energy codes impact the home in home construction and renovations. When discussing how energy codes impact construction, it's critical to consider several key aspects, such as planning and design. So energy codes influence the initial design and planning phase, dictating the integration of energy efficiency of features and technologies such as insulation levels, window types, HVAC systems to meet specific energy performance standards. A lot of this now changed too in large production builders have somewhat had to change a little bit of theirs because you've got the 45L tax credit that brings out money. It's got to pass the Energy Star. So to be more energy efficient, some of them had to change some of their design and planning. You've got material selection as the choice of construction materials and how it's affected, which focuses on using materials that have better insulating properties, contribute more to the overall energy efficiency of the building, like energy efficient windows, doors, and high R value insulation. Then you've got construction techniques. Builders must employ construction techniques that minimize thermal bridging and air leakage to comply with energy codes, ensuring a well-sealed building envelope. That could be better air barriers. That could be putting in advanced framing techniques, ladder blocking two stud corners, three stud corners, minimizing just the impact of wood conducting into the outer air barrier or the outer shell of the building, breaking a thermal bridge in some form or fashion to stop heat transfer through the building. There's different construction techniques that can help. And then system installation, you've got system installation of mechanicals and electrical and plumbing systems is guided by energy codes to optimize energy consumption. This includes the use of energy efficiency appliances, lighting, and HVAC. But as most of people don't realize is just because the contractor did install energy efficient equipment, was it commissioned properly? Is it actually performing to the levels of its efficiency as it should? Just because they've installed it doesn't mean that it actually functions that way. So there are new programs and new certification programs that you can get to actually perform testing and measurements of mechanical systems to validate the fact that it is and is running to optimal energy efficiency levels. So there's one called HVAC grading. So instead of grading insulation, someone's grading the HVAC install. Usually it's not an HVAC contractor, but these guys have been trained to do HVAC grading to ensure that these equipments and stuff that is installed is performing to its optimal level. And even though a builder may install an 80% furnace and just a 15 SEER equipment, it's kind of base minimum for what you can do in a construction of a home today. But is it actually functioning that way? It needs to be tested and verified, and that's not part of code yet. Hopefully in the future it will be. Then you've got inspections and testing. So energy codes necessitate various inspections and performance testing, such as blower door, duct blasters. We talked about that earlier, to verify the energy efficiency of the building and ensure it complies with code. And then the cost implications is compliance with energy codes can impact the overall cost of construction and renovation, potentially increasing initial cost by leading to long-term savings that reduces energy consumption. We'll talk about more of that in the costs part of that later on in the webinar. When talking about renovating older homes, you've got renovation and retrofits. For renovations, you got energy codes may require upgrading existing structures or systems to meet energy codes or the current energy code standard, which includes maybe adding insulation, upgrading the HVAC system, replacing windows and doors. If you were part of our last webinar, you saw in 2024, they've now upgraded it in the existing building section of the code book that says when HVAC systems are changed out, they have to meet sizing requirements and they have to meet all the requirements of new code, which is new construction code. So like adding programmable thermostats, you can't just use what's already there. You've got to upgrade that to be able to meet the minimum levels of energy code compliance for new construction. And then sustainability and environmental impact. So adherence to the energy code contributes to the construction of more sustainable, environmentally friendly buildings to reducing energy consumptions and greenhouse gas emissions. Market value and a curb appeal, basically. Homes built or renovated to high energy efficiency standards often have higher market value and appeal due to the lower operating costs to enhance comfort. So this, as energy costs start to go up, people are starting to pay more attention to, how do the mechanicals look? So if you go to buy a home it's 25 years old and then you purchase it because it's in the same location that you want, it's the way it looks, you like the aesthetics of it, and then you find out the equipment is 24 years old or 25 years old, the age of the building, that kind of is a pulling a tooth kind of a thing to say that's going to be painful for quite some time. Legal compliance and permitting, so obtaining building permits and avoiding legal complications is contingent on demonstrating compliance with applicable energy codes. This varies a lot from city to city, I'm finding out. Some cities are really big on, if you're doing a gut rehab, then that house is pretty much going to meet energy code for new construction because you've stripped it down to its studs. Other cities just basically think that if it's just being better than what it was before is as acceptable. That's not for me to say one way or the other. It's just as homes get gut rehabbed because people are staying in place and like the location, like the home, or buy an older home that they want to upgrade. They do a gut rehab. It really should comply with all energy codes to get to that point, even including blower door and duct testing. Then you got consumer awareness. It's the implementation of energy code raises awareness among homeowners about energy efficiency and its benefits, fostering informed decisions and demand for energy efficiency homes. So a lot of people now we see, even though they're looking for specific locations, they may actually look for specific builders that build to a certain energy efficiency level, or they're looking for builders that have a Energy Star certification, a home energy score that's done to it. Something has been done to it to validate the fact that they do build the energy efficiency measures. They don't just say it on their website that, oh, we build energy efficient homes, and it may not be even close to energy code or its bare minimum. That does mean they're energy efficient compared to previous codes. That doesn't necessarily mean that it's better than you think it's going to be. So by understanding these aspects, builders, renovators, homeowners can better navigate and the implications of energy codes on home construction and renovations, balancing compliance with cost effectiveness and sustainability. So a lot of times it's almost a trade-off of, do I buy this super high efficient or better looking gas stove or electric induction stove, or do I spend more money for better windows? It becomes a trade-off on what you want to do. So permits, you guys probably know the majority of how this thing works already. So building permits are official approvals issued by local government agencies that allow individuals or contractors to proceed with a construction or remodeling project. They are required to ensure that the project plans comply with local standards for land use, zoning, and construction quality. Obtaining a permit usually involves submitting plans and paying fees to a local building department. Most cities are now requiring energy documents to be turned in. If you're not doing that now, hopefully in the future, your cities will get to that point. These documents usually consist of preliminary or projected reports telling the city the intentions on what they're going to do for complying with the energy code. This report also tells the city and the inspectors the insulation levels, the window values, the equipment efficiencies, the presumed air leakage data from blower door and duct testing. And the energy inspector or energy rating company information should also be listed and verified by the city that they have registered as a regular contractor, have the proper certifications, and they are not expired, to perform energy inspections and testing within your city. That should be bare minimum of all of them. Treat them like any other contractor that's out there, because all of them do appreciate the fact that they're playing in the same level playing field and not others out there that have let their licenses or certifications expire and are not up to date on the newest codes that are out there. The inspections that happen, so once the permit is obtained and construction is underway, various inspections are conducted at different stages of the project to verify the work complies with the approved plans and applicable building codes. Inspections are technically or typically carried out by certified building inspectors or energy raters who assess it for safety, workmanship, and adherence to regulations of construction. If any violations are found, then they need to be addressed before the projects can proceed. These processes are crucial to ensuring the safety, the legality, and the quality of construction and renovation and in renovation projects and new construction. They help in preventing substandard construction practice that lead to safety hazards or increased energy use of the building. The energy inspector or energy inspections performed on new construction consist of an air barrier visual inspection, usually before insulation, then an installation quality inspection, which is they're grading how well the insulation was installed, and then a final inspection is used to verify the air barrier, attic insulation, and lighting, and the appliances and equipment that's been installed, and they compare that to the referenced home or preliminary report stating that they're the same. During the air barrier or insulation inspection is usually when the duct testing is done. This test does not find or locate air leaks. Instead, it verifies the air leakage and it's meeting an at or below acceptable level based on CFM or cubic feet per minute, based on square footage of the conditioned home. And then during the final inspections or after all penetrations to the outside have been sealed, a blower door test is performed, which verifies by air testing the air barrier that was previously visually verified during the first inspection. This test does not find or locate the leakage. Instead, it only measures the total leakage to verify it's at or below acceptable levels based on the conditioned volume and number of occupants the home is built for. For example, a 3-bedroom is 4 occupants. You can use other things like smoke pencils or smoke machines to help locate and pinpoint these leakage tests, but right off the bat, these tests only verify compliance for a specific air leakage test. It doesn't point out exactly where it is and exactly what needs to be fixed. There were so many times I had builders say, well, what do I need to fix? I don't know. It's failing the test. Well, that doesn't help me. Well, I can't really do anything to help you further other than saying it doesn't pass. And so you have to look at anything that's consistently built for the air barrier and the thermal boundary or the air boundary of the home. You have to go back and look at it. I know a lot of it's covered up. You can't see it. You have to do your best to see what you can do to air seal that. After the final inspection, all testing has passed. The energy rating company will use the field data collected to run and reevaluate. It's called a confirmed energy report to confirm that what was built and what was preliminary reported that was going to happen did, either at the level of compliance or better than compliance. This is the true and final energy report based on all inspections and testing data that determines the estimated annual energy cost for that specific house or building. And it's just an estimate. If you have a 3-bedroom, 4-occupant home and you've got 6 people living there, it's going to be outside of that realm. And the estimated annual cost won't match because you've got more energy consumption happening than what it was designed to be for. And then energy codes and home sales. you've got energy efficiency ratings. So there are various energy efficiency ratings that can be implemented into new construction. Each of these come with their own challenges, their own additional construction costs. All this has to be weighed when you're actually building a home to say, how far do we want to take this? What's the importance of saving energy? So you've got base code, which is, it's kind of like it sounds. It's the lowest that you can get. It's a house built to code, only is the least energy efficient home that can be built to state law or current law or city law or local regulations. Then you've got the home energy rating system, or rating, the home energy rating score. One of them is called the HERS index. This is the index that's used. It's kind of like the miles per gallon on your car. It can tell you at a glance how efficient the home is. But in the case of a lower score, the lower the number, the better. Homes using a VA loan process must obtain a HERS to qualify, or at least a home energy rating score to qualify. Unfortunately, most loan officers don't really request this till the last day of closing. And then when that comes up, then suddenly people have to go and jump through hoops to get that. I mean, I'm sure third parties on the call today hear that and just laugh about it. It happens all the time. You get a phone call from a mortgage company saying, we need this HERS number or this energy score. I don't know what this means. What do we have to do? And then you have to stop everything and take the next 2 days to try to figure out if it's compliant and what's its HERS or energy score number. Then you've got Energy Star. It's much more than just the Energy Star appliances. So a lot of people, when you ask, "Oh, did you buy an Energy Star house?" "Oh, yeah, it's got Energy Star appliances." It's way beyond that. On top of basic energy code inspections and testing, additional testing is required, additional to pass. This includes HVAC system testing, room-to-room balancing airflow testing, bath fan and kitchen exhaust flow air testing, and then documentation verified, just to name a few. LEED for homes, which LEED stands for the Leadership in Energy and Environmental Design, uses Energy Star as its backstop for energy efficiency. And then, but it also takes it to a whole new level. So it's environmental upgrades. It's from site sustainability. It's from the site that it's built on. So it has whether previous building sites already on there, or is it brand new construction on a newly developed plot that didn't previously have anything on it. All the way down to what type of glue is used in the carpet. They focus on sustainability, resiliency, indoor air quality, durability, and increased lifespan of the building. We used to say that a code built house would last 50 years and a LEED built house would last 100 years. It's just built differently on how the resiliency and durability is more of a focus. Then you've got Passive House. This is a program that's for ultra low energy buildings that require little energy for space and heating and cooling, which reduces the building's ecological footprint. There are also hybrids to these. For example, if a builder wants to stand out or the owner or developer is passionate about energy efficiency, they may choose to have upgraded items such as tankless water heaters, higher efficiency of HVAC systems, or fully encapsulating the home with foam insulation, but they're not certifying the house. In other words, they're code, but they're building Energy Star like, or they're building LEED like. They're not going to certify, but they're going to do additional measures to be more energy efficient. And those are the things that seem like the builder was going to go, more energy efficient. In reality, it might just be the fact that they're doing this to pass base code. For example, if you do a foam encapsulated house and the whole house equipment is inside the thermal envelope, it sounds way more energy efficient on the surface. But if they choose to encapsulate and you're going to use gas appliances, you cannot use the less expensive 80 AFUE furnace. So it's due to safety concerns. It'll use the oxygen out of the attic and produce bad carbon monoxide. So they have to go with a more energy efficient 90 or 94 AFUE furnace. But they use that as marketing to say that we're really energy efficient. We're doing this great. This is what we're doing to meet those things. But it may also be the fact that they chose to go with an easier applied foam insulation, but now it changes the equipment requirement and you have to go with upgraded equipments to get there. It's not a bad thing. It's not that I'm trying to bash on that part of it, but if you change one thing, you may have to change another. And they're doing that because they still have to meet code and its safety concerns and safety requirements. So energy efficiency and property value. A lot of people, there's still arguments today on if I went to go sell my house and everything that I've done to it so far, how do I get credit for that? How do I get the value back of what I thought that I put in? There are multiple ways to value and increase the property values with energy efficiency improvements. For example, increased value, that's just basically right off the bat, energy efficient homes often, they say, and if you look on the internet and do the research, they say often that the higher market value compared to less efficient ones. Studies have shown that a dollar decrease, for every dollar decrease of annual energy consumption, the market value in return on that increases by $20. So that's, can you get that back? Is that me saying that you can update your home's price to meet that $20 per every dollar that you spent? No, it's based on your area. So Tim's got regarding replacement of electrical resistance furnace, must you use the high efficiency heat pump replacement, or can you replace? That is a tough question, Tim, and the straight answer right off the bat would be yes, you have to go heat pump. The second would be, can you get by without doing that? Yes, if you use a res check and you do a simple prescriptive compliance pathway, they can get by with that. If you use any other pathway, it's going to penalize the electric resistance furnace with too much energy consumption. It's going to fail the energy model all day long. So yes, we always told people, hey, if you've got electric resistance, you got to go heat pump. There's no other way around it, except when you're doing a like-for-like replacement of a home and no one's really running an energy model or sizing calculations, it's tough to say no to that, because if you read the code book, it doesn't specifically say that you can't. But when an energy model is built or ran on a home, it's going to tell you the energy consumption is too high. So anytime someone asks me that question, it's always your best bet is to replace it with a heat pump that is way more efficient and will cost you way less than electric resistance furnace. I did that for my dad. He was hesitant on a heat pump. He had one in the 80s. He didn't like it. He said it didn't meet the heat requirement most of the time, but we were in a colder climate when we had it. And here it's going to meet the heat requirement for a home all day long. So yes, I would say that regarding that and doing a replacement, you should request that they go with the heat pump. You can't enforce it. It's not code. It's not anything you're going to read in there to say that they can't, but it really should not be used. Attractiveness, and that's a good question, Tim. Thank you. Attractiveness to buyers. Homes with energy efficient features are generally more attractive to potential buyers. Features like Energy Star or energy efficient appliances, windows, insulation can also be used as a selling point. A lot of times, though, if the stickers aren't on the windows and the sheetrock's over the insulation, how do you verify that? How do you actually tell a homeowner or a potential buyer that I did this, I did this, I did this, and it actually means that? You have to, and the next phase here is certification and ratings, is to get it validated. So homes with energy efficient certifications or good energy performance ratings can command a premium in the market. So certifications like Energy Star, LEED, or the Home Energy Rating Score can add several thousands of dollars to your property's value. So it can also reduce time on the market. So energy efficient homes tend to sell faster than homes without energy efficient features. Buyers value lower utility costs and smaller carbon footprint, but a lot of them, if your realtor isn't up on that and they don't request the energy bills or maybe a 12-month rolling energy bill from the current homeowner, you may get down to closing and go, we forgot to look at that. And then suddenly you're going to be paying more than you were hoping to with energy bills. Or if it's important to you, you don't have as small of a carbon footprint that you thought. So getting it validating and getting in certifications, if you're a current homeowner and you look to maybe sell later on, you've done some improvements, maybe look at hiring someone for an energy audit. We'll talk about more of that in a minute, but just to validate that what you did actually made a difference, and that equates to dollars in market value. You got mortgage benefits. Some mortgage programs offer benefits like lower interest rates or reduced closing costs for homes for energy efficient features. We talked about a while ago that a VA loan actually wants a HERS or a home energy rating score. Then you've got long-term savings. While energy efficient homes may have a higher initial costs, the long-term savings of those energy bills can be offset by making a better investment in energy efficiency. Environmental impact, you got beyond monetary value, you got energy efficient homes contribute to environmental conservation by reducing energy consumption and also in turn reducing the greenhouse gas emissions. Pretty soon you'll start seeing that on if you haven't already, start seeing that on marketing flyers or pamphlets or on websites for builders, is listing their carbon footprint for each of their homes or their reduction in greenhouse gas emissions, because that's a big thing right now. And a lot of people look for those kind of keywords. And there are a lot of people with websites, and drawing people to more of their websites will immediately say, we are energy efficient. We certify by X, Y, and Z. We have a lower carbon footprint. We reduce greenhouse gas emissions by X, Y, and Z, and doing different things and setting themselves apart. While the exact impact on property value can vary depending on location, market conditions, specific features of the home, energy efficiency is generally considered a viable or valuable attribute to real estate. So being considered with, if you're looking to sell pretty soon and you think, every time I go up there and change my filter and I look around and see that the insulation in the attic is just poorly done, or it's really old and it's compressed, or there's a lot of stuff in it that doesn't look really good, just paying an extra $600 or $800 or $1,000 to spray more foam, to blow attic insulation over the top of existing attic insulation, could really impact the selling feature of the home. Just those little things that don't cost a lot. Homeowners looking to see or increase their property value should consider investing in energy efficient improvements and obtaining relevant certifications that we just talked about. From a buyer's perspective, if you're looking to purchase a home, there's so many things to look at. The aspects, of course, it's initially, thought of as location, 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 and then what schools are around there, et cetera, et cetera, et cetera. These days, the cost of energy consumption is becoming more important for the decisions when purchasing a home. People are looking at it, and you see the area, and you look at what's the utilities, who am I going to have to pay, and I've heard those guys are expensive. Let's see if that house is energy efficient. If it's a co-op, it may be more expensive than someone that's larger for a different public utilities. But where do you start? What is your consideration, and what is all included in determining energy efficiency levels of the home? So key features like, does it have HVAC systems that are efficient? Are they new? If they're relatively within the last 5 years, you could probably bet that if they've been maintained properly, they're relatively efficient. They don't meet today's standards, but they're relatively efficient. And then energy efficiency appliances, Energy Star appliances, windows. A lot of times you can just Google the model number. It'll take you straight to the website. You can look it up and say, are those Energy Star appliances? Because a lot of times Energy Star labels or stamps might be on the outer portions of the equipment or the appliance that's installed, and they're removed. And so you don't really know that unless you look up the model number. And just because it's one brand like Whirlpool doesn't mean that every single appliance that they make is Energy Star certified. It could be that their bottom level line isn't, but everything beyond that is. And so just to say, oh, it's Whirlpool, it's got to be energy efficient, doesn't mean that it is. And then questions to ask, like, what's the home's energy consumption? Ask for utility bills. Everyone now, is people that I talk to now, real estate agents do that a lot. First thing they look at, well, can we get utility bills? And so the seller is usually now accustomed to already having to produce that. It's easy. You go to the website, you can download all 12 months by PDF, and you can just email that to the real estate agent, and you can just take a look at that. But comparing that and saying, is that energy efficient? All you're really doing is looking at what's the outlay, what's the average cost monthly for me to heat and condition this home or run the lights or have the TVs. You don't know what that homeowner has in the house. They could have way more than what you do, and your bills will be less. They may have a lot less than you do, and the bills will be a lot more. But it just gives an idea of, wow, the summer bills are already going to be $600, $700 to cool a home, or even in the winter to heat the house because it's electric resistance heater. That's a big red flag of that's not very energy efficient. And then you've got where there are any energy efficient certifications. So if someone has done their work and does their due diligence and gets something to validate as a certificate, they should present that to the real estate agent, and you'll be able to have that and look at it when you're looking at the home. And then verify energy efficiency claims through utility bills, certifications, or inspection reports. If you're buying a new home, third parties have already done the work. They've done the inspections. They have reports. You have a preliminary and you have a final or confirmed rating on the report, or final energy inspection report. That's something you can request when purchasing a house. Can I see the reports? I want to know that it's been tested. I want to know that it's been inspected. I want to know that someone did a pre-drywall inspection. I want to know that the air barrier has been tested, that the duct system has been tested. So those are things that you can ask, and so you should ask when you're looking to purchase a new house. So energy efficiency isn't complete without asking that question: how much is this going to cost me? Let's look at some of the financial aspects of energy efficiencies. Of course, there's short term. This is the hard cost of just making the improvements, or the cost of it being included in the price of a new home. If when someone says we build the Energy Star, oh, it's probably raising the cost $5,000 to $8,000 a house. Maybe, I don't know that for sure. I'm just throwing out numbers. But that could be cost associated, the short-term hard cost to buying energy efficient. But then you've got the long-term cost. In other words, what's the return on my investment? What's the ROI? But how much is this going to save me annually, monthly? A lot of people get tied up with that when looking at short-term costs. They see sticker shock, but after that, the payment for doing that, the energy savings don't just stop. So yeah, you purchased a $15,000 energy efficiency equipment. Whether you pay it all up front or you pay it in monthly payments, or you pay it out in some other way, once it's paid for, those savings continue for the life of that equipment, and that should always be considered. It doesn't stop saving you anything. Most of the time when a contractor is selling you a product or service like energy efficient windows, HVAC systems, radiant barrier, more insulation, they always do a cost benefit analysis sales pitch. And I say that because I did that for years. I sold radiant barrier, I've sold windows, I sold insulation. I did home assessments, I did energy audits. We looked at it and did an HVAC comparison. We tried to upsell for HVAC, and you just do kind of a cost benefit analysis. They put all this stuff, all the math on paper. They show you the initial cost versus the estimated savings from making the improvements, and then they calculate the return on investment, or your ROI. They focus on that really heavily. If everyone's gone through a window presentation or HVAC presentation has a comfort advisor, they're going to go through a lot of this, and a lot of it makes sense. But as always, take these with grains of thought, or grains of salt. Do your own research. They will always adjust or inflate numbers in their favor. I mean, there are reputable companies out there that won't. They'll tell you just as it is. They'll let you make the decision. But if you're really trying to sell radiant barrier and it's just rolls of aluminum with Mylar in it, and it's got holes in it, and it's going to be stapled to rafters, it doesn't have an R value associated to it, how do you now tell them the cost benefit analysis? I mean, you can't really relate it to an R value increase because there's no R value listed. You have to show them in energy savings from historical examples or the science and data that's been put together from a lab that says, I'm going to equate this to what it's going to do for you and save you money. So it's been said that most people don't stay in a house longer than 7 years on the average. So when I did sales like that, that was the number we lived by. So it was always try to get that ROI at or below that average 7 years. If you did that, most people saw that as a good purchase or a good investment. If it was outside of that, most homeowners would look at it in this way: why should I pay all the upfront costs for someone else to benefit from? That question was asked for me a lot. And the question is asked that way, and if the salesman does not know how to counteract that question, they'll lose the sale. So if you can't come up with a great answer that makes sense, you lose any opportunity to continue to make the sale. It's got to make sense by numbers to people, but what they need to understand is, yeah, you're right, the ROI is 11 years, but after that 11 years and you've paid it back, the savings don't stop. They continue. And you can use that as a selling feature for your home in the future. That's things that hopefully salespeople have learned to be able to talk about that and be able to offset the question of, why should I pay for this and let someone else benefit? It should never really be the end result of, I'm going to be that selfish that I'm not going to help the next person buying the house. If you're going to sell the house anyways, try to find a way to, well, can I have documentation of this? So when I go to sell the house, I can turn that over to my real estate agent that can then broadcast that to any buyer so that they know that these improvements have been done and it resulted in a lesser reduction of my energy bills. An easier way to look at that too, if you do radiant barrier and you have 12 months prior and then 12 months the last 12 months and then 12 months prior to that, you can say, this is the date I added radiant barrier, or this is the date I added energy efficiency equipment, and you saw the reduction in the utility bills. That's a way to validate that what you did made a difference. There are other ways to pay for energy efficiency improvements or lessen the impact of that. There's a whole lot of government grants that are out there, new and extended programs offering tax credits, rebates on energy efficiency improvements. Most manufacturers have their own rebates or incentives also offered for their appliances. And then you can turn right around and get tax credit or utility rebates. So local providers, utility providers also provide assistance and possible bill credits for enhancing efficiency items. So for choosing that. Most people are unaware of the energy efficient mortgages, the EEMs for short. That's been around since 1980. So sometimes now it's being referred to as the green mortgage because that's the new buzzword is green, or energy efficient mortgages is as it was once known. This type of mortgage will allow borrowers to borrow more money than the price of the home to pay for energy efficiency improvements. The cost of the improvements are now spread out over the life of the loan. For a good example, so if the home is listed at $300,000, it's been shown that a $25,000 improvement investment would lower the energy consumption, say for example, 30% when the home is purchased, of the home being purchased. Then the escrow account can be set up for $25,000. So you can get the loan for $300,000 with an escrow of $25,000. As the energy efficient work is done, a draw is made off the escrow for payment to the contractors. Eventually, all the work is completed and the energy savings start happening. And then, of course, to the lenders, this can sometimes be the means to ensure stability with the loan. So meaning that this should allow homeowners to better budget and pay for the home mortgage payment instead of having higher and abnormal bills during the summer or winter, making it harder to budget for paying for the home and unexpected bills that now they have to pay for this higher energy consumption for the house. So it's a way to spread that out through the life of the loan to pay that out. But I went down that rabbit hole of asking anyone that I talked to that's in the mortgage industry, oh, do y'all do energy efficient mortgages? It's either one of two answers. I'm sorry, what is that? Or, yeah, we don't have anybody in our office that does those. It's a government program. It's out there, and all mortgage offices should be able to do it. The program's out there, and it can happen. That's a way that people can get into a home. They've got the location they want, the schools they want, the aesthetics that they want. Well, now they've done all the efficiency improvements, and they have technically a brand new house compared to more energy efficient homes, and it's a better way to do that. It should be an easy and simple solution, but it's always a lot of pushback because it requires a lot more work. You've got to do preliminary testing, and then you've got to do final testing. You got to make sure that what was told that was going to be done actually got done. So you have to actually find someone to do inspections to be able to look at part of that to make sure that it's being done. And then, of course, the homeowner has to educate themselves and find a good contractor that knows that the reason you're doing this is for energy efficiency improvements, not just because you want to put in a new HVAC system. So improving the efficiency of the home can lead to lower utility bills, a smaller carbon footprint, but also making the home more comfortable of a living environment. So if there's ductwork issues, if there's duct leakage, if there's inefficiencies in the equipment, the home can be a lot more comfortable, and you won't be, well, I like the fact that we got where we got, and I like the fact that we got the home that we got, but now I'm miserable at night. And now you're looking at buying a new equipment or trying to fix the old, and no one wants to deal with it. They just want to talk to you about replacements. But here are several ways to improve your home's energy efficiency, of course. Insulation, weatherization, that can also be paid by the energy efficiency mortgages, increasing the insulation, not just the equipment, but sealing around windows and doors. Proper insulation prevents heat loss, keeping the home cool in the summer and warm in the winter. Seal around windows and doors, weather stripping windows, attic stairs, other openings to the outside or to unconditioned spaces like attics, crawl spaces, unconditioned basements. Heating and cooling systems, so upgrade the HVAC with a more energy efficient and correctly sized system. Get a proper load calculation before the system fails and needs replacement. So if you're in a home currently now and the system is older than 10 years, find somebody that'll probably charge you $250 to run an energy model. It may not be perfect, but you're going to get a more closely aligned sizing of the equipment. So when the day comes and the system dies in the middle of the summer, you're not scrambling to get air conditioning, just going like for like, just doing a complete swap out because you have to. And then suddenly you've made the wrong choice of equipment. Because now this equipment is more efficient because it's newer. There's less leakage in the ductwork because it's newer. And now when it was leaking 1.5 tons, like my personal house was, even though I had a 4 ton, it was acting as a 3 because I was leaking a ton of air. Now it's not. Now the home is uncomfortable because balancing issues and just on and on and on. Use programmable thermostats to lower and raise temperatures when you're away or asleep. Maintain all aspects of the system. Replace or clean the filters as directed, both in the unit and possibly in the mechanical ventilation system. If you have a new home, the mechanical ventilation system, if it's a standalone fan, will have a filter installed. If it doesn't, you need to have it installed, and then make sure that you replace that once every 6 months because it will just be a thin 1-inch filter. It used to be said it was a little easy to say, well, change your filter out every month, and people would just, on a religious basis, monthly go in there. Now systems come with 6-month filters. People just set it and forget it, and then out of their mind, and then you go a year down the road or more, and oh crap, I've never changed the filter, and it's affected efficiency and the equipment. It's lowered the life of the expectancy of the equipment because it has to work harder. Also had the outside coils cleaned annually. And also, this is contradicting to a lot of people, especially my wife when I talk to her about it, using ceiling fans only when you're home. Moving air around doesn't lower the temperature. It basically just more evenly distributes air and moves air around. It also blows off the warm air that's against your skin. It does not lower air temperature. So when you're not home, don't use ceiling fans when you're not home. Heating systems, so when replacing that, consider installing more efficient equipment. We talked about that. Getting a sizing calculation to make sure that it's the correct size. Insulate any accessible water heating pipes, reducing any heat loss. This can be like the pipes coming out of the top of the water heater if the insulation has deteriorated or if never there. Make sure that, or any pipes also exposed in the attic. Newer homes have PEX piping in the attic that should be insulated. If they're not, maybe take the chance to, even though they might be under insulation, a more densely packed pipe insulation on there would be better. Use low flow water fixtures. So older faucets used to come easily with, you could just remove the aerator and stick a new aerator in that had a low flow gasket. Modern day fixtures now, they come with built-in aerators. They're not really easily removable. The low flow feature was done when you purchased the equipment. It should say on the box what its gallons per minute is. With shower heads, you can still install a gasket that lowers the low flow rate. A lot of people do not like those at all. So there are new shower heads that have different ways of mixing air with water that feels like you're getting more water and feels like you're getting more coverage and more power out of a lower flowing shower head. So look for that on the appliance or on the box when you do the purchasing. Do your research. Google has a lot of them out there. Lighting and appliances, use energy efficiency light bulbs, switch to incandescents or CFLs, or switch out any incandescents to CFLs, or better yet, even the LEDs. Choose Energy Star appliances or something that shows it's an energy efficient appliance. Turn off lights and appliances when not in use. Unplug phone chargers when not charging the phone. Set up timers or smart switches to add routines that keep you from having to remember to turn off and on things. Well, I've done that in my house because there are things that I want to come on and to go off. I don't want to forget about it and leave it on all day, including a pool pump, just making sure it comes on at a certain time and goes off. That way I don't just leave it running 24/7. Windows and doors, when replacing and installing energy efficient windows, double or even triple pane windows with thermal breaks or low E coating can also greatly reduce heat gain inside the house. Use thermal curtains, sometimes referred to as solar curtains or solar blocking curtains, can lower the heat gain from the west and south facing windows. Upgrade doors to an insulated or better air sealed door frame. Landscaping, of course, a lot of people don't see that as, if you plant a tree, of course, you may have to wait 20 years to get it full size, but planting shade trees strategically, providing solar shading and wind breaks to the west and south facing of the house. Of course, if you have solar panels, you don't want to block it by a tree. That's another kind of offset of that. Plant shrubs, kind of where they'll shade the foundation walls that are directly exposed to sunlight on west and south facing walls. So if you do that, then you block the heat gain from inside that slab area. So I recently had carpet pulled from my house and used vinyl flooring. Now, if I walk around barefooted, I can really feel if I go to the south or west side of the home, that heat in the summer is radiating anywhere from 4 to 6 feet inside the house. You can tell a difference by walking barefoot on that floor, but shading that foundation wall will stop that, to keep that, because that floor is just radiating heat up inside the building. Use solar lighting, basically on any of the outdoor lighting, and then renewable energy, of course, if possible, install solar panels to offset energy consumption. Other ways to improve. So ask for energy reports. We talked about that earlier. If you have a brand new house, ask for the energy reports and put that in a folder. Have that readily available when you go to sell your house in the future. That will be, in the future, will be valuable information that will help you stand out from other homes being sold in your area. So if it's built within the last 10 years, chances are you've had an energy model or energy inspections done during that process, during the build process. If you know the builder, if you're buying it new, you know the builder. If you're buying it secondhand or you're the third owner of the home, you don't actually know who built it. But sometimes you can call their office if you know the builder and request a copy. Sometimes you can look up the community name and it will tell you the builders that were in there, and you could hopefully find out from other neighbors who that builder probably was, and you can just call them in. They keep them for multiple years. And now that it's digital, they keep them even longer than that. So you can request a copy of that. Look into getting an energy audit or energy assessment done. Sometime your city or utility providers will offer free audits or free assessments and make recommendations for improvements. So your home may also qualify for weatherization assistance offered by state, city, or local counties. That sometimes can do a lot of air sealing, additional insulation, weather stripping, things like that. Then you can now not spend that money on equipment. You can now use that to you can spend that money on equipment, not on additional insulation that was part of your weatherization group, that your assistance that came through. Collect the data. So by gathering your own information about insulation level, windows, HVAC, energy efficiencies, and then heating efficiencies, this information can be useful for you in the future improvements. So if you do any HVAC improvements, keep that documentation in the same folder. It will be valuable information to future buyers. And then, of course, we talked about it earlier, is seek certification. So if you make a bunch of energy efficient improvements, let's say you've done weatherization, you've air sealed, you've increased the insulation, you've changed out the HVAC system, you've changed out the windows, good chances are you'll be able to find someone that can probably validate that through a certification. We talked about it earlier with the DOE product development of the home energy score. Have a certified assessor come out. Sometimes real estate inspectors can help do this too, but as they learn more about doing the energy assessments, they look at it from the standpoint of, now I can put this data into a software and get it validated by a score. That score can be used as a selling feature in the future for homes. So that wraps up today's webinar. I hope you guys found some things interesting and you had some takeaway points that you can use in conversations with people in the future. I just kind of wanted to put that together. I just felt like there was a lot of people that ask me these questions when I'm out and about. And plus you guys get CEU credits for this as well. We'll take care of that through Kathy. I've already put in for the request for the course ID for this one. So I appreciate you guys being here. Don't miss out on our upcoming webinar. We've got Tuesday, October 3rd at 10:30 a.m. There was a correction had to be made from previously it said p.m. If you already registered, I sent out a reminder yesterday that basically adjusted it to a.m. We've got Erica with the ICF Inner City Fund speaking to us over the overview of IRA and the IIJA funding mechanisms for building efficiency improvements. And as always, here's my contact information. Be sure and share that with anybody that you want that needs or wants to help, need some advice for energy efficiencies. If any code officials that are out there, you guys want to set up a training with me, by all means, please let me know. Just email me, call me directly, text me, we'll get it worked out. I've got free 2021 IECC code books to hand out during those presentations or trainings. And as always, I thank you guys very much for being part of this. Thanks for the feedback that we had. Tim, thanks for your question there. Also, if you've got any, I'll just say this, I'll try to mention it in every single one. If you guys have any pictures, photos, funny stories of doing energy inspections, by all means, send them my way. I will credit you in our webinars as I show them on the slideshow. So thanks again. Hope you guys have a great week. Enjoy the rest of your day, and thanks for joining us.